Preston just joined us and he asked the question, how is Snō coming along? And so let me address that first. And thanks for the question, Preston. So one of the questions that, or one of the things that's happening with Snō is, so Snō is really the second board that we've done, and I've got one right here. And this is our compact footprint of the XLR8 board. For those of you who don't know that may be joining us and haven't seen our XLR8 board, XLR8 is a small Arduino Uno form factor board that's based on an FPGA. And the Snō board is a real small compact footprint version of it. And the original plan we had with Snō was to have this available to ship at the end of June, and we ran into a bit of an issue with FCC testing. We want to be able to have the FCC logo on the back. We want to be able to claim full compatibility with FCC testing, and we hit one of two tests that they do. So there's a Part A and Part B testing that really splits FCC between compatibility or compliance, I guess, between essentially industrial commercial use and home hobbyist domestic use. It's weird for me to think of an electronics board as being domestic, but I guess that's the terminology they use. And so with this first version of the board, we passed everything for industrial and commercial use, but the requirements are more stringent for home use. So we did a bit of a tweak to the layout. We changed a couple of the parts and we respun the board. That part actually just passed FCC testing yesterday. I believe they tested it. So we just got notification that that's ready to go, which means we can build up some more prototype boards, build up a small lot of boards that we can make available for sale. So I would imagine, Preston, if you keep an eye, we'll probably make an announcement if you're on our emailing list. Otherwise, just check out our website. Probably sometime next week, we should have a better idea of when we'll have initial boards for you. So I hope that answers your question. So everyone's familiar with the Arduino Uno, right? Pretty ubiquitous, used in all kinds of stuff. It's an awesome board. It was an awesome idea, and it has given the ability to do electronics and to create things to just a wide range of developers. And even if you're not into electronics or you're not an electrical engineer, they created it in a platform and they created an environment that you can use to develop the code that's really simple to use. And you can go from zero to something working incredibly fast. And so it's just a really cool space that's just been growing like crazy. And I probably don't need to tell any of you that story. Well, the start of XLR8 really goes back to early 2015 when we were doing some work with FPGAs, and we were doing some FPGA acceleration work specific in the area of really high-end computing for genomic sequencing and doing essentially hardware FPGA offload with big Intel-based servers and things like that. And so we were specifically looking at very complex algorithms and how to push those off onto an FPGA to speed them up and be able to do parts of the genomic sequencing processing faster. Around that same time, we're in the Midwest, and so we're located in Eau Claire, Wisconsin, which is not too far away from Minneapolis, Minnesota. We went over to an Altera event they have every year called March Madness. And it's put on by Altera, which is now part of Intel, but at the time they were just Altera. And they were really focusing, every year they do this, and they focus on the main technologies that they're going to be talking about or really pushing that year. Whatever's new, whatever's exciting, what's going to be happening, in what they really want to push for the coming year. And that year, the focus was on the FPGA, the Max 10. And that's what we've got on our boards, is the little FPGA, the Max 10. Now, this is a really small one. They make bigger ones as well. But as FPGAs go, it's really down on the small side of their FPGA line. You know, Altera, Intel makes really, really huge, very powerful FPGAs, and they make the smaller end. And Max 10 is an interesting beast because it's a lower end FPGA. When I say lower end, I mean smaller, right? But it's got some really interesting functionality in it. So it's got onboard ADCs. It's also got configuration memory on board on the FPGA. And what that means, which is different from other FPGAs, is that you don't have to have an external memory sitting on the board to configure and flash an image onto the FPGA to get the functionality you want. It's resident on the FPGA itself. And that's a really cool feature to have. And in addition to that, Max 10 actually has two of them. So you can basically have a backup plan if you're using it and you want to change the functionality or you want to do field updates to it. It's a really handy device, very clever design. So we came away from that meeting and we were working on this FPGA offload stuff with these big high-end servers, and we thought, this Max 10 chip is really neat. We should see if we could do something with it. We had some engineers that were between projects at the time, And this whole idea of Arduino and what was going on with makerspace and IoT was really interesting to us. And we thought, well, gosh, maybe we could do some kind of FPGA acceleration for the Arduino Uno. So originally we thought, well, let's make a shield. So I've got a Wi-Fi shield here, Adafruit Wi-Fi shield. Well, let's make a shield like this with an FPGA on it, and then people could use it with their Arduino board, and they could offload things that are just dragging that little microcontroller down, slowing it down, not making it operate very effectively. Well, we realized not very long into thinking about that any performance gain we would get by running something on an FPGA and accelerating it would be eaten up just transferring the data back and forth from the Arduino board to the FPGA. The I/O speeds are slow. There's no way to get the data back and forth, so that really didn't make any sense. So we started thinking about, well, maybe we can just do the acceleration right on the FPGA, which means we would have to design our own AVR core to go on the FPGA as well. Now, interestingly, at the very same time, our president was working on building a drone at home. So he'd bought a big kit. He wanted to assemble one on his own. And he was basically using Arduinos as the nerve center for it. So we had a bunch of sensors, and we were really looking at some autonomous things. And he got part of the system going, and what he discovered was it was kind of happening independently as we were finishing up this sequencing thing and starting to learn about Max 10. He bumped into the situation where he was trying to read sensors, and he was trying to run that into his feedback loop and control motors and do all that, and it was working with one motor and one sensor. But then as he started adding additional pieces for the rest of the motors and the rest of the sensors, the whole thing just went down. And that was a great example of something we said, well, this is something you could do easily on an FPGA, because you could push that processing logic to handle all the data, the sensor data input, and how to make decisions with that, even the control loops to feed that in and handle controlling the motors. That could all be put out on an FPGA, and that would handle that data rate, no problem, could do it all in parallel. And that really was kind of one of the clinching things when we put our desire to do something in the Arduino space with our experience doing FPGA acceleration and FPGA design, along with this concept of putting it all in one package. We came up with the idea of let's give it a try. Let's go ahead and make an FPGA-based Arduino board that actually has the the Arduino capability, the AVR, built right into it. And this was actually our very first board. So this is our Rev 1, I guess you'd call it, or maybe Rev 0. It's green, and we had the JTAG over on the side so we could program it. We put the ICSP header up here, which I'm not exactly sure what we were thinking when we did that. But anyway, this was Rev 1 of the prototype, and it worked. We got it back and it worked. We could program it with the Arduino IDE, and that was pretty exciting, which that, of course, led to the next revision of it, which we switched to the blue board, and we moved some things around. We changed some of the electronics, and then that's kind of where we are right now with this version of the board. So it's been really cool. And one of the things that makes Accelerate unique is basically the fact that the microcontroller is on the FPGA. They're not two separate chips. So you really can take advantage of the power of the FPGA on the same chip that you've got the AVR. And you can program this with the Arduino IDE, so you can use it just like an Uno board. You can plug it in, you can upload your sketch, and you can run it. And if that's all you did, it would run just like an Arduino Uno. You could do just about anything that you would with a standard Uno, you could do with one of these. Now, where this starts to become more powerful is when you take advantage of the hardware acceleration that you can get with an FPGA. And that's what you get with what we call accelerator blocks. And accelerator blocks are essentially just the blocks of logic that you can put on the chip to accelerate certain functionality. And we've got accelerator blocks for servo control. We've got it for controlling NeoPixels, which NeoPixels are great. This is one of my favorite NeoPixel accessories right here. It's the 40 NeoPixel shield from Adafruit. I love this because with this device and a simple sketch, you can draw people across a conference room floor from like 100 yards, and they'll come over and check out what you've got. So great accessory. And you can drive NeoPixels because a lot of the libraries that exist for driving those LEDs sort of have to stop the microcontroller in its tracks on a standard Arduino because it can't be interrupted just due to the way that they operate. But we've kind of removed that complexity, and then we can just handle that no problem. We've got some stuff for doing a little bit higher end enhanced ADCs, and we've got other accelerator blocks that are coming along. And so what we're starting to see is some of our customers are using these, and they're able to just take projects where they're using an Arduino, take servo control, for example, where maybe you've got this jitter problem, and you can just use our board. You could use the accelerator block for controlling the servos, so all the servo control is actually happening from hardware in the FPGA, and then that gets rid of the jitter issues, that gets rid of the problem with overloading the processor, completely offloads it from the microcontroller, and allows that microcontroller to have more time to do other things. So it frees up functionality, or frees up basically processor cycles, microcontroller cycles, to do other things. So you get a performance boost when doing that also. And then we added the ability to do basically custom accelerator blocks. So if you are comfortable doing logic design, if you can write Verilog or VHDL and you want to design your own FPGA blocks that you can put onto our board, you can do that also. And so we have a process that we call Open Accelerate that shows you how to do that. And that's actually undergoing a bit of a change right now that will probably push out in the next month or so. We're trying to make it a little bit easier for people to do. We know it's not terribly easy to do right now, but there is a path for doing it. We do have customers that are using that methodology. So there you go. That's kind of the story. That's Accelerate and where it came from. We talked about earlier when I was answering the question about Snō. The next logical step was to say, okay, people like this form factor. People are using it just like an Arduino Uno, but they want to be able to do something in a much smaller footprint. So can we give them that? And the Arduino Minis were really popular. There are all kinds of Arduino compatible boards and really small form factors that are very popular. And we wanted to be able to provide our customers something similar. So with the Snowboard, in addition to having the same functionality from the AVR compatible microcontroller and the FPGA acceleration there, it's in a small footprint. You actually get more I/O. We brought out some more of the I/O onto the board, so that's usable. And it seems to be going over pretty well with the customers who have bought it so far. We have sold a few specifically to just industrial customers that we know they're integrating into something else in a commercial application, and that's going really well. So we're excited about this. We're excited for having the next one available very soon that we can ship out to you. One of the things I'll say as well about Snō is that Snō has an FPGA that's larger than what's on Accelerate. So Accelerate has what's called the 8K version of the Max 10 FPGA. So there's essentially 8K LUTs that you can take advantage of, the logic elements that you can use to do the design. And our AVR core itself takes up a non-trivial amount of that space, but it leaves that extra space for your custom XBs. We've gone up to the 16K version for Snō, which means that even though we've only bumped the available logic space by 2, it actually results in more like 3 to 4 times the space for your custom logic, because the AVR microcontroller stays the same. So it's going to end up working out pretty well, I think, for the customers that want to use that. All right, so that's our story on Accelerate right now. And I'm just kind of checking out here. Let me scan down and see if we've got any other questions. Doesn't look like we do right now. So I think that's about it for today. I know that, as I said, we're right in the middle of the afternoon. We wanted to kind of do something sort of impromptu and something quick and easy for people to join in if they were available. This kind of thing might work better if it's done in the evening, or maybe with a little bit more advance notice, I guess, but wanted to give people a chance to jump in and ask some questions if they could. So I think with that, we probably aren't going to sit around here in the silence for too very long, but maybe what we'll do is we'll try doing another one of these again, perhaps in a week or so. We'll give people a little bit more warning and let them jump on board, and we can just kind of interact with them for a while. So feel free. I know this is going to stay up on Facebook, and we will continue to watch the questions and the comments as they come in. So ask your questions and make any comments you want. We'll be glad to ask them. We'll make sure we're keeping our eye on it, and we'll get you guys answers either directly on the Facebook, or we'll reach out to you in some way so that we can answer the questions you have about our boards. So anyway, for those of you who are here watching, really appreciate you. Thanks for the question, Preston, and we'll keep an eye out for more opportunities to do more of this for you, and we'll make sure we're communicating when Snō is ready to come out and some of the other cool things that we're doing here at Alorium Technology. So hope that you guys have a great Thursday afternoon. Thanks for joining us, and we'll talk to you again soon. Bye.